Hey everybody, sorry I couldn't be there today, but I did put together a quick video trying to explain how to do two different types of factoring. The first is going to be a difference of squares, and the second one is going to be on factoring by grouping. Pull out the worksheet. I believe we're on page 2, and what I'm going to do, like I did yesterday, is explain how the entire process works. I'll show you a couple examples, and then I'll give you some time to actually work on this worksheet. So in terms of factoring a difference of squares, what we have is anytime you have two perfect squares separated by a minus sign. And a lot of people call this a difference of squares. I like to call it the plus-minus rule. And the reason I like to call it the plus-minus rule is because this will always factor to a plus b times a minus b. Now, you may be asking, where on earth did that come from? Well, let's check it out. If I distribute, so if I distribute the a and then distribute the b, no matter what a and b are, so a could be negative 57 and b could be x to the 50th. If I distribute, I get a squared plus ab, or minus ab, plus ab, minus b squared. These two middle terms are going to cancel each other out, and I'll be left with a squared minus b squared. So basically, this just shows me the rule works. If I have two perfect squares separated by a minus sign, I can simply take a plus b times a minus b. So let's see how that actually plays out in a problem. So if I had x squared minus 9, well, first I need to figure out what a would be and what b would be. Now, to do that, all I need to do, since this is a squared, is x squared, b squared is 9, is take the square root. So I'm going to take the square root of x squared, and I'm going to get x. And I'm going to take the square root of 9, and I'm going to get 3. And notice that I didn't actually include the minus sign. I'm just going to look at the x squared and the 9. So what do? Well, I take those two answers, and I do plus minus. X plus 3, x minus 3. Sorry, I wrote 9 for some reason. 3. And that's your answer. Now, the cool thing about this, and my nerdy math I think is cool, even if we have a number in front of that x squared, it actually still works. So all I need to do is take the square root of 9, which is 3, and the square root of x, or square root of x squared, which is just x. And that's my a in this case. For the b, I just take the square root of 16, and I get 4. So what is this factor to? Well, plus minus. 3x plus 4 and 3x minus 4. And there's your answer. So as long as I have two perfect squares, and as long as they're separated by a minus sign, my plus-minus rule works. Now, before I set you off to do the worksheet on your own, I do want to look at one more type of problem that looks a little scary, but really isn't that horrible. So we are going to look at x to the 4th minus 16. This is a very special problem. Now, the first thing you're going to notice is that that is not an x squared. And so you can say, well, Davis, how do I take the square root of that? It's actually pretty simple. Basically, whenever you take the square root of x to some power, all you do is divide that exponent by 2. So instead of x to the 4th, we'll have x squared. So, for example, even if I had the square root of x to the 6th, that just becomes x cubed. If I have the square root of x to the 10th, that becomes x to the 5th. So basically, you just divide the exponent by 2. Back to our problem, we take the 16, take the square root of that, and I get 4. I don't know what happened there. So, what does it factor to? Well, plus minus. X squared plus 4 times x squared minus 4. And you're almost done. Now, the reason I say almost, well, look at our two answers. Here, I have x squared, which is a perfect square, and 4, which is a perfect square, just like types of problems I had up here. The only difference is I have a plus sign. If you have a plus sign there, you cannot factor further. You get x squared plus 4. That is the most you can do. But look at x squared minus 4. Well, x squared is a perfect square. 4 is a perfect square, which means I have to do my rule again. So my new a is x, my new b is 2, and I get, let me change the color. So my new a is x, my new b is 2, and my answer is x plus 2, x minus 2. So this one actually has 3 factors in its final answer. X squared plus 4, x plus 2, and x minus 2. So, at this point, head over to the next page, and I have a whole list of questions for you to be able to answer. I'll tell you that number 9 is going to have a number of different sets of parentheses. Oh, actually, never mind, because that's going to be a 10. Scratch that. So that factors once, and it looks like all of the rest of them except for number 15 are going to factor once. So with number 15, you're going to end up factoring maybe 2 or 3 different times. So at this point, you can pause the video and give a little bit of time to go through and try each of these on your own. After a couple minutes, you can replay the video and you'll see me put the answers up on the board. So here I go. All right, at this point, you should have been able to finish off the rest of the sheet, and you've got your answers up on the board. Apologize for the craziness. This pen is not my friend today. Now, if you notice, I stopped at number 15. Okay, again, we said that if you want to take the square root of an exponent, you simply divide that number by 2, which is where the 12 came from. So, at this point, the x to the 12th plus 1, I can't do anything with. But x to the 12th minus 1, well, I can divide that 12 by 2. So I am going to do my plus minus rule to x to the 12th minus 1. So my x to the 12th minus 1 becomes x to the 6th plus 1, forgot the 1, and x to the 6th minus 1. Now, as for that x to the 12th, it actually stays there. X to the 12th plus 1. Well, but then, let me clear off some room. You may notice, well, we're actually not done yet. We can actually do x to the 6th minus 1 again as well. So we get x cubed plus 1, x cubed minus 1. Now, Davis, is it going to be that hard on the test? No, not really. There is going to be something like that on the RQA for the third marking period. So part of this is me kind of prepping you for the fact that you may have to do this again in the future. So there you go. That's the final answer for number 15. Like I said, that's the toughest one. Don't expect to see that difficulty level on the test. I just wanted you to see it and get an eye for it before the RQA. So let's turn over to the next page, and we are going to start factoring by grouping. Factoring by grouping. I'm going to zoom in a little bit further. So factoring by grouping gets its name because you find two groups. Yeah, surprise, surprise. So what I'm going to do is I am going to cut this into two different groups of terms. You have the group on the left and the group on the right. And all I'm going to do is common factors like we did yesterday. I'm going to look at 12 and 9 and say, is there anything that I can divide 12 and 9 by easily? And the answer is, well, yeah, 3. So I'm going to start with that. I'm going to divide 12 by 3, and I get 4. I'm going to divide 9 by 3, and I get 3, minus 3. Well, then I look at the variables. Here, I have 3 A's, and on this one, I have 2 A's. So what I'm going to do is I'm going to factor out 2 A's, or I should say an A squared, which means if I remove 2 A's, I have 1 A left here, and I have no A's left over here. For the other one, I'm going to do the same thing, except I don't see anything in common for the 4 and the 3, and this 3 doesn't have an A. So what do? I put plus 1. So if it doesn't look like they have anything in common, just use plus 1. And you write 4A minus 3. Now this is the weird part. This is the really weird part. So bear with me. What we have now is we have each of these groups has a 4A minus 3 in common. So just like I've done in previous questions, what I'm going to do is I'm going to remove that 4A minus 3 and put it outside a bigger set of parentheses. So I am going to remove a 4A minus 3, and just like we did over here, so when we removed a 3 from both of these terms, we just put 3. We didn't put 3 squared, we didn't put 6, we didn't put 9, We just put 3. So for this, I'm going to remove a 4a minus 3 from each and give it its own set of parentheses. Well, what happens to the leftovers? Well, now I take the 3a squared and the 1 that are left over, and they get their own set of parentheses. And I get 3a squared plus 1 times 4a minus 3. And that is my final answer. So, why did we do this? What does that mean? Well, if I was to multiply this back together, I would get 12a cubed minus 9a squared plus 4a minus 3. Well, and if you look at this, minus this random line, that is exactly the same as our original problem, just like we've done in all of these other factoring problems. So the whole goal of factoring is basically to rewrite something as multiplication, and as you'll see in another week, we are now able to use these answers to solve more complicated problems. So what I'm going to do now, I'm actually going to scroll down and do number 3 because I'm too lazy to scroll right. And I'm going to show you one more example. So we are going to cut into 2 different groups. And if you notice, I cut to the left of that sign. So I'll cut to the left of that plus sign. And I have one group that is 3n squared minus 4n. And the other group, 9n minus 12. So I start by looking at the numbers, 3 and 4. I can't think of anything they can divide by, so it looks like I'm going to be stuck with a 3 and a minus 4. Then I look at the variables. Well, I have 3 n's on the first term, 2 n's on the second, so that means I can pull 2 n's from both of these terms. Well, if I remove 2 from this, I have 1 n left over. If I remove 2 n's from this, I have no n's left over. So the first group factors to n squared times 3n minus 4. For the second group, well, 9 and 12 can both be divided by 3. So I'm going to do a plus 3. So don't forget to do the plus sign. You'll see why in a little bit. Plus 3. And I'm going to have 3n minus 4. Because 9 divided by 3 is 3. 12 divided by 3 is 4. And since they don't share any n's, that would be my answer. And again, for the confusing part, we're going to take the two 3n minus 4's, and they combine together into one 3n minus 4. Now, for the other part, we have the leftovers. Change my color. So I take the leftovers, n squared and 3, and those get their own set of parentheses, n squared plus 3. So my final answer, n squared plus 3 times 3n minus 4. Scroll down to number 7. I know. I'm going all over the place. For number 7, the reason this one is unique is because when I split it down into 2 different groups, I have a minus sign. So when I do this one, well, and it's got this XY thing. So calm down, we'll get through it. We have a 35 here and a 5 there. So the left side has a 5 in common. 35 divided by 5 is 7. And they also have an x in common. So I'm going to remove the x from this group, and I have a y left over. I remove the x from that group, and I'm left with minus 5. Now, let me show you what happens over here on the right. If we have a minus sign, I know I am going to pull a minus as part of my common factor. So, I'm going to look at this and I see, well, I got a 56 and I have an 8. So they both can be divided by 8. So instead of factoring out a plus 8, I'm going to factor out a minus 8. Now when I do that, I take negative 56 and divide by negative 8, which gets me a positive 7y. And I'm going to take 8 and divide it by negative 8, and I'm going to get a negative 1 instead of a plus 1. And for those of you that already caught this, I made a mistake over here on the left. That should have been a 1. So, if there's a minus sign in the middle, you must factor out a minus, which switches both of the signs. From there, we do the exact same thing. Those two combine into 1, 7y minus 1. And my leftovers go in my other set of parentheses, 5x minus 8. So my final answer, I have 5x minus 8 times 7y minus 1. So, take this top opportunity, go through the rest of the page, and I want you to try to factor by grouping for the rest of these. Actually, why don't you just go... You do 2, 4, 5, 6, and I'm going to throw in 10. So 2, 4, 5, 6, and 10 are what I want you to do. So good luck. I'll show you the answers in the meantime. And I'm going to be checking this tomorrow, so I hope you guys get it. And I'll try to answer any questions you have tomorrow.